In this section, we're going to look at operations with radicals. Now, if I were to ask you what 5x plus 4x minus 3x simplified into, you'd say, well, I know how to do that. That's combining like terms. I've been doing that in my algebra classes for a long time. That would be 9 minus 3 is 6x. Well, if you have simplified radicals, then you can do the same thing. 5 radical 2 plus 4 radical 2 minus 3 radical 2 is 6 radical 2. A simplified radical behaves just like a variable in a polynomial. Let's look at another problem. The square root of 50 plus the square root of 1/2. Now you say those aren't like radicals. Well, that's true. They're not like radicals, but they're also not in simplified radical form. So we're going to put each one of these in simplified radical form and then see what happens. 50, the square root of 50 is 25 times 2, so it's the square root of 25 times the square root of 2. That would make it 5 times the square root of 2. We want to add that to the square root of 1/2. Well, the square root of 1/2 is the square root of 1 over the square root of 2. That means we'd have to rationalize. So we've got 1 over the square root of 2, because the square root of 1 is 1. And we'd have to rationalize this. And we wind up with the square root of 2 over 2. So there's our problem. Here we are. 5 radical 2 plus radical 2 over 2. Now we do have like radicals. The only radical here is radical 2. So what do we have to do? We have to combine 5 radical 2 and, what is this anyway? It's really 1/2 radical 2. So we really just have to do 5 plus 1/2 radical 2. I did that using the distributive property in reverse. I factored out the square root of 2, leaving behind the 5 and the 1/2. So what we have now is, probably don't want to write that as a mixed number, so we have 10 halves plus 1/2 is 11 halves radical 2. So when you first look at a radical, you might say, well, I can't combine it with this one over here, but make sure if they're not in simplest form that you put them in simplest form first.